Okay, second video here. We are doing intro to chapter 3, which is all about how to use equations and calculus to tell us what's going on with graphs. So, today we are focused on what's called the first derivative test. Spelled that wrong. There we go. So what I would like to do is draw a relative maximum. Draw a relative maximum in front of you on whatever you have to draw on. All right, hopefully you drew this. And then my question for you is, how does the derivative change at that max? How does the derivative change at that max? Well, left of the derivative, f prime is, or left of the max, f prime is positive, and then right of the max, f prime is negative. So how does the derivative change at the max? F prime changes positive to negative. All right, we're going to ask the same question at a min. So go ahead, draw a relative minimum, and then answer, how does the derivative change at that min? Minimum, negative derivative, positive derivative. How does the derivative change? It changes from negative to positive. Okay, cool. So that's essentially what the first derivative test is, but we need to give one definition first. So I'm going to pause for a moment and write a definition here. Okay, so our definition is for the term critical value. A function f has a critical value if the derivative, which is f prime, is either 0 or undefined. So I'm going to give you two examples. I'm going to use f prime equals, open parentheses, x plus 3, close open, x minus 8, close squared. That's my first f prime, or my first function. And then we'll say g prime equals 1 over x squared minus 1. So let's look at the first example first. So look, notice I said if f prime is 0, then f has a critical value, right? So here I'm giving you f prime. You don't even need to take the derivative. But f itself, f has a critical value at the two spots that make this thing equal to 0. So it should be pretty obvious to you that x equals negative 3 would make f prime 0, and then x equals 8 makes f prime 0. If I had given you f instead of f prime, then you would have taken the derivative, but I've already done that work for you. So this thing has a critical value at x equal negative 3 and positive 8, because that's what makes it 0. All right, let's talk about g. G here is a fraction, and it's got a 1 on the top, so I can't make that fraction 0. But I can make fractions undefined by putting zeros in the denominator. So what I like to do when I have something like this is to factor the bottom, difference of two squares, to make sure that I get all the pieces, x minus 1 times x plus 1. And then you can see that it is dne at x equals plus or minus 1. So those are the critical values of g. Having that term critical value is going to help us when we write out the first derivative test. So I'm going to scroll down. I'm going to write out the first derivative test, and then when I pause it, and then I'll explain it, and you can write it down as I'm explaining it. Okay, so this is the first part of the first derivative test. I'll read it out loud and give you a chance to go ahead and write it. The first derivative test, what it does is it finds relative mins and maxes on a function. It says if f is continuous and f prime changes positive to negative, which we can write as plus arrow minus, positive derivative to negative, positive derivative negative, then f has a fill in the blank. What are we going to put there? If the derivative changes positive to negative, then f has a relative maximum. Hopefully that makes some sense. What we've been doing so far has kind of been getting ready for that, and it might just make some sense. So there's a second half to the first derivative test, and it looks really similar. If f is continuous and f prime changes negative to positive, that would be going negative derivative to a positive derivative. So something changes from going down to going up. Well, then f has a relative what? Minimum. Good job. All right. So if I can show that this happens, that one of these changes happens, then by calculus, I have justified that something either has a relative max or a relative min. So let's jump into a quick example. Here is my example. All right. So identify and justify any relative min slash max using the first derivative test, colon. All right, so I want to do it with y equals x cubed minus 12x minus 5. Now, if we had a calculator, we could graph it, but this is something that we are doing without a calculator. And it's good to be able to do things without a calculator, so we can do it on our own. All right, so here are our steps. Step 1, find the derivative. So when I find the derivative, I get y prime equals, power rule is 3x squared minus 12. Next step is to, and this is why we defined critical values above, is to find any CVs. Now, if you remember, let me scroll back up to what we defined critical values as when f prime is 0 or undefined. So remember, though there's various things that can make a derivative undefined, but typically you're looking for a 0 in the denominator. Since this is a polynomial, it's defined for all values. So instead of looking for zeros in the denominator, we're just looking for the derivative itself to be 0. So what I'm going to do is write 0. Oops, let me stick with purple. 0 equals 3x squared minus 12. Okay, so there's a variety of ways to do this, and I think there's a better way. You may, and this is good if you have this intuition, want to move the 12 over, divide by 3, and square root. But I'm going to show you a different way. So this is the same as saying 0 equals, I'm going to open or pull a 3 out because there's a 3 factor in both those. Open parentheses, leave a gap, and close. Now I'm going to fill in what's left. Well, I need an x squared, and what do I need to get to that 12? I need a 4. And then that gives me 3 open parentheses. That's difference of two squares. You should know how to factor that. I get x minus 2 times x plus 2. And this is equal to f, or sorry, not f, we're using y in this case. So y prime is equal to this. So what are the values that make this 0? Well, x equals positive 2 and negative 2, which I can write as plus or minus 2. If you factor, then you're less likely to miss the negative one of these, because if you move it over and square root and stuff, you might forget the negative. And as you'll see in a moment, this form right here is going to be useful for us. So the next thing that I'm going to do is make a chart. Make a chart. Now, this chart is going to become a way for us to organize our information. We still have to make a statement at the end, especially with regards to the College Board and accepting our answers and giving us full credit. So, what's my chart going to look like? It's going to have 3 rows. The top row is going to be x values. It's going to be related to these plus or minus 2. The next row is going to be f prime. And actually, all I care about is whether f prime is positive or negative, so that I can look at when these changes happen. And then the last row is going to be f, and this is going to help me visualize what's going on with the function. So if you think about x equals negative 2, or plus or minus 2, I have various intervals. I have negative infinity up to negative 2. That would be negative infinity up to the first of these two, if I'm going in order. And then I've got the range of values of x from negative 2 up to positive 2. And then lastly, I've got the values of x from 2 up to infinity. So what I've done here is I've made some intervals, and the transitions of the intervals are the critical values. So now what I need to do is look to see if f prime is positive or negative in each of these regions. Because I found the spots where it is 0 and this derivative is continuous, I know that if I can show that if the derivative is negative or positive at one point in this range from negative infinity to 2, or negative 2, or negative 2 to positive 2, or 2 to infinity, if I can figure out whether it's positive or negative at one spot in those, then I know what it is for the entire interval. So I'm actually going to start with this one right here. And I'll show some work, although eventually you're probably going to skip this particular work. So I am going to find f prime of 3, or I'm going to start to find f prime of 3, because 3 is the first whole number in this interval. I can't do 2 because I know that y prime, not f prime, is already 0 because it's a critical value. All right, y prime of 3 is equal to, all right, I have this 3, open parentheses. If I let x equal 3, I get 3 minus 2. And then I get 3 plus 2. What really matters here is that these things in the parentheses, this one's going to be positive because it's a positive 1, and this one's going to be positive because it's a positive 5. So what I have is a positive times a positive, which is going to be positive, and I circle that overall value. I only care if it's positive. I don't care what the actual number is, okay? So I'm going to next test a value in between negative 2 and 2. I think there's an easy one for me to test here, and it's 0. So if I test 0, I'll write it out, y prime of 0 equals. All right, I get my 3, that's this. And notice, remember, I said that this is a valuable form, and that's what I'm using right now. I'm using that factored form of y prime, because all I need to know is if it's positive or negative. So I get 3, open parentheses, negative times a positive, negative times plus, so it's negative. The next one I'm going to check is y prime of negative 3. And that gives me, it gives me a negative times a negative, which overall is going to be a positive. I'm not going to go over that because I'm sort of running low on time here. All right, so what do I know about f? Well, if f prime is positive, then f is going up. And if f prime is negative, then f is going down. And if f prime is positive in this range, then f is going up. So I think you can see that it goes up, and then at negative 2, it transitions to go down. I'm going to get a max at negative 2. Similarly, I'm going to get a min at positive 2. So the last thing I need to do for the first derivative test, this is step number 4, is to make statements. All right, and this is what the AP cares about. If you remember, come back up here, it says, the first derivative test says, if the derivative changes plus to minus, then we have max. If the derivative changes minus plus, then we have relative min. So I need to write out min, sorry, we'll start with the first one, max at x equals, what was the transition value? Negative 2. Because f prime changes from positive to negative. And you can write it like this, and the AP will accept it. All right, so I get a max at negative 2. Now I got to make another statement. So let's see if you can make the statement for x equals 2. Go ahead, hit pause, try it. All right, hopefully you said that we get a min, and my chart shows it. I get a min at x equals 2 because f prime changes from negative to positive. So one thing that is common here is for people to do the chart and then say, all right, I'm done, right? You have to make these statements because you have to connect it back to what the original first derivative test says. So hopefully you feel like this makes some intuitive sense and you feel like you can follow these steps and you can use the first derivative test to find mins and maxes on functions. Peace.